Okay, before routing the board, it's good to get to know the Altium PCB editor also more. And here, if I come to the project and then place, which is better for our video, we have some other things that you can place like line, string, pad, and via. To get to know them, pad is what we have here. Actually, pad is like where the pins or the legs of the components are connected. So basically, components are connected with pads. We have two types of pads in general. We have through-hole pads, as you see. There's a hole which goes all the way in the circuit, and this is like the traditional way. And we have the SMD pads or surface mount pads that are just in one surface. So in the 3D view, if you have a look, you don't see them on the other side of the PCB. Just I've made it a bit transparent, but in reality you don't see it. And these are called SMD or surface mount footprints and pads. Also, you have vias. If you maybe we need to use vias in this PCB, maybe not. But actually, when you want to change your layers, you can place vias, and it's done by here, place via, or by pressing PV, you can place a via always. So in the routing, we'll see this more. But before getting into the routing, let's have a look at the layers and how they are actually in Altium. If I press L, then the view configuration shows up, and this is where you see all the layers and view options, what you want to see and what you don't want to see. So you see, if I turn off pads, you don't see any pads. Or if I turn off, let's see, other things, we don't have much here, but let's say 3D buddies, then you don't see them here. And this is very useful in the 2D viewer. I think it's not accessible in the 3D view. So I go back here, and you can remove or place the 3D buddy. You can also change the color of your PCB. It's in the general settings, it is traditionally green. I'm sure you've seen it, but there are other colors that you can make. Like, for example, we want to make it red, so the color becomes red. And here you can also change the sharpness. Of course, this is just in the software. When you want to manufacture it, it depends what color actually your manufacturer will put on it. So the red might not be exactly the red color that you're looking for. Anyway, in the menus, you see different layers, and you have signal and plane layers, you have component layers, you have mechanical layers, and other layers. The most important ones now are the top layer, which is the top of your PCB, like the red one, and the top part of this vias, and also the bottom layer. So if I go to the 3D view, you see that our PCB has two layers, one on the top and one at the bottom. And obviously this is all we have in this case, because we're just having a two-layer PCB. And so we just have these two layers, but we can add as much as we want in Altium, and there are no limitations. So why we should change this, there are different reasons, and I will not get into that. Actually, there are a lot of things if I want to explain about EMC, like stack up, how the layers should be planned is one thing. So we just now talk about this. As you see, we have this overlay, top overlay, and this is exactly what you see for the name or designator of your components. And you also have bottom. So if I bring some of these components by pressing L to the bottom layer, and I press the 3D view and I go back, you see, oh, it's now on the button. And there will be a different name now for the designator of a component on the back side. So, what was I think here? No, L. And as you see, I can turn this on and off. And you also have the solder. Solder is where defines the border of where the solder should be and where the solder shouldn't be. In the bottom and in top. As you see, you can remove them or you can show them, not a big deal. And you have the paste, the solder paste, you don't see it, in the bottom and in the top. You also have some mechanical parts, layers. Actually there are 3 layers. I think you can also add more if you need. And these 3D components are in these layers, so we can check on this. If you turn off mechanical 1, you see they don't disappear, but if you turn on mechanical 13, they disappear. So they're in mechanical 13. You can change their layer. And you also have mechanical 15, which is used for some bordering, things like you're not very into them. And this very important one, multi-layer, which is used, you cannot really turn it off, and it is for multi-layer. Multi-layer means when a component or a pad is in different layers, or it's in all layers, like in our case. We have the drill guide, I think it's for the holes, and the keep out. And the keep out and drill drawing. So at the end this is what we have. But if you want to have a closer look, and if I press DK or design layer stack manager, this is what I told you as the stack up of your PCB. So this will open, and there are actually a lot of things to explain again here. The printed electronics, let's forget about them. Now you see that you have your PCB structure here. You have a Fi4 dielectric, and also the thickness and dielectric constant. So the bottom layer and the top layer, they're signal, and they're 1 ounce. We can change them, I think, to different, up to 4, depending. The higher ounce are used for power circuits when they need. And other layers like top solder and top overlay and things like that. If you want to add layers, you just right click, insert layer, like you say, insert signal layers or planes. Let's say we add 2 signal layers, and then our board becomes 4 layer. If you go back to the PCB, you see we have, I need to save first. We go back here and you see now we have layer 1, layer 2 and bottom, and so we have 4 layers. And you can again add another one. Let's say we want to add another pair, and you get more layers even here. So it depends on your project and your PCB how many layers you actually require. Okay, let me, before closing it, I remove the unnecessary number of layers, because this PCB is obviously rooted in just, it is obviously rooted in 2 layers. So here we need just 1 dielectric in between, and that's all. And it's 4.8. In this case it's not important, but in high speed designs you need to know the value of this epsilon r, or the dielectric constant, and it's here. Okay, if I put it back here, then we can start with routing. So how do I connect them? As you already see, the Altium is showing us that somehow I need to connect this pin to this pin, or this pin to this pin, and this one. So this is called ratness, and it helps you a lot. You can turn it off here if you don't like it, but I recommend you to keep it on because it helps you for placement a lot. Now for placing a single wire, I come here, interactive route connections, and I can easily route from here, and it shows me also where I should route my signal. So if I place wire, place track, it's different now. PW, this shows me where I should connect it. So let's start from here. How thick these PCB wires should be depends on different factors again. Mostly it's, so it can be on top. Let's go in top. So I just open the stack up manager, I save it, then we just have 2 layers, and by pressing PT I can routed traces. If I press tab, then it comes to the menu where I can choose the width. Let's say I want to make it 20, but it doesn't allow me because I don't have the right rules set. So let's also learn a little about design rules. If I press DR, or design rules, here in the electrical we have routing and width, and as you see the maximum width is 10 mils, so it's pretty small. I make it 100 and I press OK. Now when I want to try to route it, it allows me to have a bigger one, and this is fine for this case. As you see, I move them. You can also change the direction of your movement by space again, and if you press shift space you can also change the corners. You can make it 900 degrees, you can make it like this, or you can make it as you want, but the best is usually 45 degrees. And you come and double click on the point that you want, and then it is connected. Try to keep these connections as short as possible. When you go and you want to return, you can just press backspace and you can change your direction. So it's better if I go from here because we have this. There's something, if I'm routing and if I press tab, it will open here and it automatically remove loops, and I don't know why it didn't work here, but it should. So I undo the changes and could come all the way from here, and now from here to here. So we're having good placement. The routing is pretty easy and it takes just a little effort. As you see, I'm routing it pretty easily. Since it's also a low voltage PCB, you don't have to really be worried about the spacing between them. We just have 12 volts maximum and it's nothing. I think 1 mil distance is also more than enough it needs. Now I connect the 2 volts and here we go. Now we have the grounds. Actually, this board can be routed in 2 layers without in 1 layer without a problem. I'm going to show you. So I connect them, the rest of the connections. We have some grounds. So how I can do this is pretty simple. If I rotate this one a bit and place it here, then I can connect all these ground pins. Let's say I make a bigger ground because it's better, so 50 mils, and then I connect them here. Okay. Or we can do something else. As you might know, there's something called polygon, and we can fill these empty places with a polygon. So we place polygon pour from place polygon pour, or you can just place press PG, sorry. And you can move here again with shift space. You can change your corners, and I completely cover my PCB all around. Of course, not going out because then it will be problematic for production, but there should be at least a little distance between them. I think in the standards they define something like 60 mils, which is like 1 millimeter or something space, but this is fine. And we set it to the net of ground. I still have not explained nets, but I first here say pour over same net polygons, all same net objects as it was, and also give a name to it like ground, and then I press OK. As you see, this polygon is now created, and we have all of the grounds also connected together without any problem. But if I make this a bit smaller, like 15, or yeah, it's better again, And as you see, the project is over, so we can send it to production, right? Of course not, because once it is over, then the user doesn't know what these pins are. So it's a good idea to play some things that help him. I place an S ring, put it to the top overlay, name it plus, name it plus. It's so big, so I make it 100. Also, the border is very big. Strange a bit. Let me have it here. I move it. Okay. So this is my plus. Now the user knows it's actually the plus sign. I can copy. Copying in Altium also is that you press Ctrl C and click, and it's now copied. So -1. Now it's minus. Board margin is quite big. Maybe we still make it smaller like this. That's good. We also want to know what is the input and what is the output. So the input is P3. Place, we can again copy here. For example, I put I here. And make it in a kind of Times New Roman, so that it's a good I this type. And this is our output, Q or O, for example. Again, I make it 75 and reduce the size so it does not go over the PCB. And we can put also the minus here to show it's ground, or G for example. So once it's soldered, then the user knows, okay, this is the input, this is the output, without a problem. So we have two layers, and as you see, in our case, for such a, it depends on the frequency of operation, but for such a device it's not a problem and it works fine. But it's always good that we have the polygon layer also here. So we can, for this case, we can copy the ground on top, all the plane, and by pressing EA and keep net name, paste, then we have it here. So we have two of them now, and we change the name of the layer, and it's done. So in our case, since no SMD component on top has ground connection, we actually don't require any ground, or sorry, vias to the ground. So we can easily remove this from top layer, and it's just fine. But it's not a bad idea to have ground on both top and bottom. So with this, we can say that our board is pretty simplistic board, which is a two-stage amplifier, is over. Of course, there are other things that you can make from your board, and I'm going to explain them in the next video.